Hello and welcome to another Arlington High School Math 4 Honors lesson. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson number 8 on Systems of Linear Equations. Now some of what we do today is going to be review, actually most of it is, but we're going to apply this eventually to systems of 3 equations with 3 unknowns, which is going to become difficult sort of arithmetically. Make sure to have a calculator handy, if for no other reason than just doing some basic arithmetic that we can get slowed down by if we're doing it by hand. Alright, let's begin and do a little bit of review. In exercise 1, we're asked to solve the following system of equations by A, substitution, and B, elimination. Alright, so what I'd like you to do is maybe pause the video now and see what you can remember about both of these techniques in A and B, and then we're going to go through both of them. Alright, let's do it. So, when we're doing something by substitution, when we're doing a system by substitution, what we do is we substitute one equation into the other. But in order to do that, we probably are going to want to solve this equation for y. Now I'm going to do that in my head, and it should be fairly easy, right? If I bring that 2x to the other side, it becomes a negative 2x, and then the 7 remains negative. I'm now going to take this expression, because y is equal to it, and I'm going to substitute it in here for y. That's going to give me 3x plus 2 times the expression negative 2x minus 7 equals negative 9. So I'll get 3x minus 4x minus 14 is equal to negative 9. I'll get negative x minus 14 is equal to negative 9. Add 14 to both sides, we'll get negative x is equal to 5, and x is equal to negative 5. Now obviously the last thing that we do once we have that initial variable value is that we substitute it back in. Might as well substitute it back into my y equals negative 2x minus 7 because that's already solved for y. So I'll get y is equal to 10 minus 7 and y is equal to 3. There's no real requirement that we write that as a coordinate point because it may or may not have anything to do with graphing. But there's the solution to our system. Now what we're going to be concentrating on though today is not solving systems by substitution, but solving systems by elimination. One of the fundamental properties of equality is that if you've got two equalities, A equals B let's say, and C equals D, then you can add them together to get another valid equality. Makes sense, right? I mean, if I know that two numbers are equal and two other numbers are equal, when I add them together, their sum has to be equal. We can use that to our advantage if when we add two equations together, they eliminate one of the variables. Now when we look at this particular system, if I add these two equations together, 3x and 2x is 5x, 2y and y is 3y, right? I would get 5x plus 3y. Well, nothing got eliminated, so that doesn't really particularly help me. What I'm going to do is I'm going to actually take this equation here, and I'm going to multiply both sides of the equation by negative 2, right? So I'm going to use the multiplicative property of equality to multiply both sides of the equation by negative 2, giving me this equation. And what can now happen is that when we add these together, the two y's cancel, and I'm left with negative x equals 5. So look at how quickly I get down to that line, right? I'm there very, very fast. And then I solve, get x equals negative 5. Now, of course, I've got to take that negative 5 and substitute it back into one of these two. I could easily do it in the first one. Let me show you that we get the same result for y. I get 3 times negative 5 plus 2y is equal to negative 9. I'll get negative 15 plus 2y equals negative 9 plus 15 on both sides. 2y will be equal to 6. Divide both sides by 2. Y is equal to 3. All right? So that's what we're going to be working with a lot today is the elimination method. All right? We're going to do one more problem with the elimination method that you've probably never done before exactly in this method. And then that's going to motivate our series of 3 equations with 3 unknowns. All right? Pause the video now though and write down anything that you need to before I erase the text. Alrighty, here it goes. Excellent. Let's take a look at another problem. Exercise number 2, it says determine the equation of a line in y equals mx plus b form that passes through the points negative 2, 23, and 8, negative 7 by solving a system of equations. Now you've found the equation of a line passing through 2 points many, many times before. The standard way of doing it is you first calculate the slope using the slope formula. Then you back substitute and you figure out the y-intercept by using one of the 2 points. But we're going to do something a little bit different. All right. As everyone at the pre-calculus level should know, anytime we've got some kind of curve that goes through a point, we can always substitute that point into the curve. So for instance, if I take that first point and I put it into y equals mx plus b, I'll get 23 equals negative 2 times m plus b. That's completely valid because if I know that the equation passes through this point, or if the curve passes through this point, then this must be a true statement. But I can do the same thing with that second point, and I'll get negative 7 equals 8 times m plus b. And now I have a system of 2 equations with 2 unknowns, the unknowns being the slope of the line and the y-intercept of the line. Now I've got 2 choices now. Obviously when I add these 2 together, nothing cancels because I get 6m and 2b. You could also subtract the 2 equations. That would eliminate the b's. Or if you, like me, want to avoid issues in terms of making double negative errors, I do that all the time, we could multiply both sides of that second equation, or the first one, by negative 1, and that produces for me a negative b. Now when I add them together, I'm going to get 30 equals negative 10m, obviously divide both sides by negative 10, and I'm going to get m equals negative 3. All right. Obviously now to figure out the b is not very difficult. I think I'll probably just substitute it into the first equation. 23 equals negative 2 times negative 3 plus b. 23 equals 6 plus b, and b equals 17. So the equation of my line, I should never forget to actually write down what I've been asked for, even though I've done the heavy lifting, is y equals negative 3x plus 17, easily enough checked by just seeing if it passes through those 2 points. All right, pause the video now. Write down anything you need to before we go on to harder problems. All right, I'm going to clear out the text. All gone. Let's move on to another one. Now, in the last problem, what we did is we found out the equation of a line by substituting 2 points in. Now what we're going to do is we're going to figure out the equation of a parabola by substituting in 3 points. And we're going to do exactly the same thing that we did in the last problem. We've got the generic form of a parabola or a quadratic function. We've got 3 points now, not 2 points. And we need to figure out the leading coefficient, a, the b, and the c, right? All those nice constants from the quadratic formula and elsewise. So here we go. We're gonna do exactly what we did before. I'm going to put in negative 2, and I'm going to write it like this. So 35 in for y. I'm going to put in negative 2 for x. All right. Okay, and eventually I'll write an equation over here. But that's going to, actually, maybe I'll just do it right now. I'm going to get 35 equals 4 times a. Remember, you're not squaring a. Minus 2 times b plus c. Let's put the second point in. We'll put in 5 for y. We'll put in 1 for x. Ooh, this one's coming out nice. All right, we'll get 5 equals a plus b plus c. And then finally, we're going to put in 11 for y and 4 for x. And that's going to give us 11 equals 16 times a plus 4 times b plus c. And I'm going to actually label these in a different color. I'm going to call them equation 1, equation 2, and equation 3. That way I can track sort of everything that's going on. Now, this is obviously trickier. We have 3 equations with 3 unknowns, and we're going to solve it using the elimination method. And we want to use one equation to eliminate the same variable from the other 2 equations. All right, so we want to get rid of a, or we want to get rid of b, or we want to get rid of c, something like that. Okay? Now, one thing that makes this problem particularly easier than, let's say, the next one we're going to do is that we can get rid of any one of the 3 variables very simply because all of these are 1a, 1b, and 1c. But I think what I'm going to do is I'm going to use a strategy. I'm going to eliminate I'm going to eliminate c. Okay, that's what I'm going to do. So here's what I'm going to do. I'm going to write down 35 equals 4a minus 2b plus c. And then I'm going to take equation 2 and I'm going to multiply it by -1. So I'm going to take equation 2 and I'm going to multiply it by -1. And that's going to give me -5 equals -a minus b minus c. And then I'm going to add these two together. I'm going to get 30 equals 3a minus 3b, and the c's cancel. All right, now look what we did. We just eliminated the c. What I want to do is I want to eliminate the c now in equation 3. So I'm going to do almost exactly the same thing. I'm going to have 35 equals, whoops, no, I don't want that one. I'm sorry. My apologies. I'm going to have 11 equals 16a plus 4b plus c. I'm going to again use that equation number 2 after it's been multiplied by -1. All right, I'm going to add these two together, and I'm going to get 6 equals 15a plus 3b. And now what I have is I have a system of 2 equations with 2 unknowns. Okay? Now, one of the things that makes this system very easy to solve, right, especially if I stack them vertically, it'll be easier for me to see. One thing that makes this equation particularly easy to solve is that if I add them together right now, the b's will cancel. Right now, sometimes that happens. Add them together. I get 36 equals 18a. Divide both sides by 18, and a will be 2. All right? I still need to figure out b, but what I'll do is I'll put that into either this equation or this one, whichever one's easier for you. I'll just put it into that since that's the way I drew the arrow. Need to be careful with my linear algebra. Subtract 6 from both sides, we'll get 24 equals -3b. Divide, and we'll get b equals -8. And now all we have to do is figure out c and then write down our final equation. So I think I'll take those two and I'll probably put them into equation 2. So I'll get 5 is equal to a plus b plus c. So 5 is equal to -6 plus c, and c is equal to 11. All right. Again, don't forget to write down the final equation. The final equation is y equals 2x squared minus 8x plus 11. Again, just like the equation of a line, this is easy enough to check to just see if it goes through all those points. Now that one was pretty easy, but it does illustrate the general way that we solve a system of 3 equations with 3 unknowns using the method of elimination. What we're going to do is we're going to use one of the 3 equations to eliminate the same variable from the other 2 equations. All right? Therefore, reducing a system of 3 equations with 3 unknowns down to a system of 2 equations with 2 unknowns. And then we can solve that by elimination, just like we did from the front side of the sheet. All right, pause the video now and write down anything you need to before we go on to one last problem that's pretty lengthy. All right, let me clear out the text and let's advance. Okay, let's take a look at this particular problem. Exercise 4 says solve the following system of 3 linear equations with 3 unknowns. Now what I'm going to do, so right away, I'm going to label them equation 1, equation 2, and equation 3. Then I'm going to go back to blue. Okay, so I need to have some strategy. I want to eliminate variables here. And the question is, well, how easily can I do that? Okay, let me see what I did here. All right, what I did, because I want to follow my notes, the numbers can get awfully large. This is where you maybe want to have a calculator handy. Maybe I'll even have a calculator handy. That would be a good idea. Here we go. What we're going to do is I think I'm going to eliminate the x. Now the reason I'm going to eliminate it is because it's fairly easy. It's fairly easy to actually take this equation and make that x have any coefficient we want. So let's eliminate x. So what I'm going to do is I'm going to multiply equation 2 by -4. Okay, and here's what's going to happen. I'm going to get -4x minus 20y plus 12z, and then here's where I've got that negative 37 times negative 4. And what does that give me? Let's take a look. Negative 37 times negative 4 gives me 148. All right. Now, I'm going to take that and I'm going to add it to my 4x minus 2y plus 3z is equal to 23. All right. When I do that, obviously these cancel, and I get negative 22y plus 15z is equal to 171. All right, notice the x has been eliminated. All right, so that's one of my equations. Okay. Now, what I'd like to do is I'd like to get rid of the x in this one. To do that, I'm going to multiply equation 2 by 2. All right, what is that going to give me? It's going to give me 2x plus 10y minus 6z is equal to, this one I think I can do in my head, 74. Then I've got that equation 3, negative 2x plus y plus 4z is equal to 27. Now when I add these cancel and I get 11y minus 2z, be careful, easy to make mistakes here. Oop, including the fact that that should be a negative there. I'm sorry about that, right? Because that was a negative 37, that should be a negative 74. When I add them together, I get negative 47. So I'm now dealing with this equation and this one. All right, so what variable do we want to eliminate now? We could eliminate the z, we could eliminate the y. The easiest thing in my mind to do that I see is if I took this equation and multiplied it by 2, then I would get 22y minus 4z is equal to negative 94. Of course, that's an advantage because when I now add these together, this cancels, and I get 11z is equal to, maybe I have to use a calculator here. I certainly do, but now I can follow my notes, 77. No problem, divide both sides by 11, z is equal to 7. All right, and now I have to figure out y. I have to figure out x. I think I'll take my z equals 7, substitute it into here. I'll get 11y minus 2 times 7 is equal to negative 47. 11y minus 14 is equal to negative 47. 11y is equal to negative 33, and y will be negative 3. All right, finally, I've got to figure out z, so I've got to take these two and substitute them into one final equation. I think I'll take both of them and move them up into equation 2. That one seems to be the easiest to manipulate. Maybe I'll try to carve out a little bit of space right up here. So I'll get x plus 5 times negative 3 plus 4 times 7 equals negative 37. X minus 15 plus 28 equals negative 37. X plus 13 equals negative 37. Subtract 13 on both sides. Whoops, wait. Something went horribly wrong there. What happened? I don't know. Oh, I see. My eyes skipped a line. I apologize. Apparently, a Monday morning, I'm making quite a few mistakes. That's supposed to be a negative 3z. Minus, right? It's right here. My eyes skipped a line, and I picked up this one instead. I'll tell you, always check your work. Minus 3 like that. Now I got to get rid of this. That'll be minus 21. Let me get rid of all of this. That'll be faster. And I'll get x minus 36 equals negative 37, and x is negative 1. All right, so there we have it. Again, my apologies for the mistake, but the general method is pretty straightforward. Is it easy? No, but it's straightforward. We choose one equation, or better yet, we choose a variable that we're going to eliminate from 2 of the 3 equations. All right, we eliminate that variable by adding opposites, and then we're reduced down to a system of 2 equations with 2 unknowns. Once we have that, we then choose another variable to eliminate, we get rid of it, and now we have only one unknown left, which we can solve for, typically quite easily too. We then back substitute that unknown into one of the two previous equations to get the second, and then back into one of the three originals to get the third. Hopefully, we do it correctly. All right, pause the video now, do whatever you need to do, and then we're going to finish up the lesson. All right, here we go. Okay, so today we saw how to solve systems of linear equations, just x to the first, y to the first, z to the first. Don't get that quadratic confusing. In that quadratic that we worked with, we were solving for a, b, and c. They were all to the first power. So we were solving systems of linear equations by using the elimination method. And the new piece of that was 3 equations with 3 unknowns. Stick with it. Make sure to have your calculator handy and check your answers. All right, I want to thank you for joining me for another Arlington High School Math 4 Honors lesson. My name is Kurt Weiler, and until next time, keep thinking and keep solving problems.